Welcome to CERAWeek 2015 online. I'm Roger Cranenberg with IHS. I focus on the global power sector. And with me today is Gaëtan Bonhomme, CTO of Kurion. Gaëtan, welcome.
Thanks for having me.
Oh, you're welcome. First, we'd want to sort of start off with, tell us a little bit about your technology and what's unique about it, and obviously the space it's applied in.
So Kurion is a technology innovator in the space of waste management, especially nuclear waste management and what we call mixed waste, when nuclear elements are together with hazardous materials. And we have a whole suite of technology going from access, which is usually when you're dealing with nuclear waste, you need to be able to access it in a way that's cost efficient and prevents the workers from facing the radiation. Once you've done access, you need to separate the technologies into a water stream that has no radionuclides into the water stream, and then a dry stream, which is where all the radionuclides are, and it's dry so that it's not in contact with the environment. And finally, we kind of close the loop with a suite of technologies that do stabilization. And this is where we've brought most of the revolution of what we brought. Is we're putting what we call glass making, which is the process of taking radionuclides, putting back into a rock-like substance, glass.
Yeah.
And we're kind of closing the cycle. So you extract uranium from the ground, that's where it is, you enrich it, you use it. In the process, we generate a lot of waste, and then you have to close that cycle, and that's what we do with our suite of technology. We make the radioactive elements go back into the rock form where it can be stably and sustainably disposed of in the ground where uranium is coming from. So that's basically kind of that promise.
So it's well sealed and there's no sort of
problems
afterwards. Yeah,
it's glass. Glass is like a rock material, and they're getting leached by the seawater for centuries and millennia, and so that's the promise that we're delivering. And we're delivering that in a really modular and revolutionary complex in the way that basically the cost is very competitive with actual methods of disposals which are not as stable over time.
So tell us a little bit about how things are going, the launch of the company, what's your potential market, exciting times I can imagine.
Well, yes and no. I mean, Kurion, was created in 2008 with one premise, which was to make the world of nuclear clean, safe, and secure. And everybody talks about dirty bombs. Everybody is always worried about nuclear. It's not carbon producing, but is it safe inherently? And what do we do with the waste? And we've decided to tackle the whole part of nuclear that has to do with, aside from all the geopolitical environment, anytime there is a technology challenge to dealing with the waste, we tackle that. So we started that in 2008, and as everybody knows, in 2011 the disaster of Fukushima happened. Of course, we didn't call for that. We were not in favor of such things, but it happened.
Tell us a little bit more about what you're playing a very key role in the Fukushima cleanup. Tell us a little more about that.
I kind of glow in the dark. I was the project manager for Kurion. We were 6 people at the time. In March 11, when the catastrophe happened, and I was on the ground for about six months, and we deployed a very unique, first-of-a-kind technology to take out cesium-137 out of the water. Cesium-137 is the #1 on your list of bad actors because it is a hard gamma ray and it goes through pipes and steel, basically. And so if you have workers on site, they get heavily affected by cesium-137. So there is a list of about 62 radionuclides that you look at, fairly well known. That's the top one on the list, and they needed that removed right away. And so we worked with TEPCO, the owner of the plant, and in a span of about 5.5 weeks, we designed, built, transported, and started up 700 tons of equipment.
Holy cow.
Yep. So that was a lot of work. I wasn't sleeping much, but that's kind of created the DNA of Kurion, of getting things done. So.
Excellent. That must have been a fascinating project.
Yes, absolutely.
You were also telling me a little bit about some of the other elements that are not as controversial, but much more difficult to remove.
Yes, that's correct. So there is tritium.
Yeah.
Tritium is basically hydrogen plus 2 neutrons, and it tastes, feels, and behaves like water. Hydrogen is.
I'm not sure I would taste it.
You can't taste it. Well, actually, tritium is used in fluorescent lights. It used to be used in exit signs. And it creates that kind of bluish glow in spent fuel ponds, and that's why people kind of associate it with kind of a bluish lighting color. But as you can see, I'm not glowing blue.
Oh, that's excellent.
Even though maybe with the background. And so tritium basically is like water, and it's been very hard to remove. At Fukushima right now, they're stuck because they have basically generated an amount of water that still contains tritium. It's about 1 kilometer long by 100 meter wide by 8 meters. So it's basically many, many, many football fields of water. And it contains tritium that's 100 times above regulatory release limits and 40 times above their yearly release limits. So they would have to dilute the water 100 times, and then they'd have to let it go out of the site over the matter of 40 years to be able to get rid of it. So what we're trying to do is provide a technology that does that in about 5 to 6 years. And basically prevents the removal, that's the need for disposing of it at sea or in the air. We capture it basically into a solid dry form that's about yay big.
Oh, excellent.
So pretty exciting stuff. So we're doing a demonstration over this coming year. We won a competition, and if everything goes well, we'll start implementing that solution. So.
Excellent, and very exciting stuff.
Yes,
and thank you very much for joining us.
Thanks for having me.
Thank you. Thank you for joining us at CERAWeek 2015 online.